Utilizing these 5 main components can help us graph rational functions. The first thing we're going to want to take a look at is our domain. And to find our domain, we're going to look for all our x values for which f of x equals 0. So basically, we're just going to want to set the denominator equal to 0. So 2x minus 4 equals 0, 2x equals 4, and then x equals 2. So that means our domain for this function is going to be all real numbers except for 2. Then our second component is going to be solving for any excluded values or discontinuities. And in doing that, the first thing we're going to want to look at is our wholes. And to find any wholes, we're going to want to factor the numerator and the denominator. And if there is the same factor in the numerator and denominator, that's going to be our whole. So if we factor both the numerator and the denominator, we'll have minus 2. And when looking at that, we can see that we do not have equal factors in both the numerator or the denominator, so we won't have any wholes. So what we will have is a vertical asymptote. And to find our vertical asymptote, we're just setting the denominator equal to 0, which we've already done. So that means our vertical asymptote is going to be at x equals 2. Next, we're going to want to solve for any horizontal asymptotes. And I'll just put a line here so we won't get that confused. So next, we're going to want to look for any horizontal asymptotes. And to find horizontal asymptotes, we're going to want to compare the degree of the numerator and the denominator. So when looking back at the equation, we can see that our numerator's degree is greater than our denominator's degree. So that means that it's going to be oblique, or also known as a slant asymptote. And this only happens when the degree of the numerator is greater than the degree of the denominator. And to find our slant asymptotes, we're going to want to do polynomial division. And to set that up, we're just going to put our denominator on the outside and our numerator on the inside. To make it easier, I'm going to put a place holder just for this degree of x, which ultimately doesn't change the value of the original equation. So first we ask ourselves, how many times does 2x go into x squared? And that'll be 1/2 x times. So now you multiply that back out. 1/2 x times 2x equals x squared. And 1/2 x times -4 equals -2x. Now we subtract that, and we have x squared minus x squared equals 0. That'll cancel each other out. And 0x minus a -2x is going to equal a positive 2x. And then we just bring down this 9. So we ask ourselves again, how many times does 2x go into 2x? And that's kind of obvious. 1 time, that's going to be positive. Now we multiply that back out. 1 times 2x is 2x. 1 times -4 is -4. And then we subtract. 2x minus 2x is 0, which cancels each other out. -9 subtracted by a -4 is going to be a -5. And we stop here because this degree is smaller than this degree. So that means our -5 is just going to be our remainder. So now we know our equation for the slant asymptote is going to be y equals 1/2 x plus 1. And in this case, we don't worry about the remainder. So now that we have our equation for the slant asymptote, we can go ahead and look for any intercepts we may have. So first we'll solve for our x-intercept. And to do that, we'll set our numerator equals 0, which is x squared minus 9. And then x squared equals 9. And then x is going to equal a positive and negative 3. So that means our x-intercepts will be at 3, 0 and negative 3, 0. Now our y-intercept, we're going to set all the x values equal to 0 and then solve for y. So 0 squared minus 9 over 2 multiplied by 0 minus 4. That simplifies to negative 9 over negative 4, or 9 over 4, which equals 2 and 1/4, or 2.25. So that means our y-intercept is going to be at 0, 2.25. So now we can take a step back and look at all our information. Our domain is going to be all real numbers except for 2. We're going to have a vertical asymptote at x equals 2, a slant asymptote at y equals 1/2 x plus 1, and an x-intercept at 3, 0 and negative 3, 0, and then a y-intercept at 0, 2.5. So using this information, I previously graphed our equation. We can see our domain of all real numbers except for x equals 2. We have our slant asymptote at y equals 1/2 x plus 1. We have our x-intercept at negative 3, 0 and 3, 0, and our y-intercept at 0, 2.25. And I went ahead and just picked some other points within different intervals to get a shape of the graph. So I picked 1 and 4 and 7 and 4, and that gave us just an estimate of what our graph would look like.